Hey guys, it's Mrs. Ullrey, and in this video we're going to learn the following things. So after watching this video, you should be able to explain and differentiate between the terms of limiting and excess reactant. You should be able to interpret a particle model of a reaction and identify which reactant is limiting and which is excess. And you should be able to create a particle model to represent the products of a reaction. So let's begin. To kind of help you understand these terms, limiting and excess, we're going to start with a demo. So what I would like you to do before I hit play on this video is think to yourself, what would run out first? The oxygen in the room or the wax in the candle? So let's watch this video. So this is time lapse, so it's going pretty quick. Okay, and we can see that that candle is completely burned up, like completely consumed in the reaction. And so the wax is going to run out first because there is a limited supply of the wax, while there's an endless supply of oxygen in the room. So we have oxygen in the room next door, and outside. So we have an endless supply of oxygen. We are limited to the amount of wax that the candle is made out of. So then now we're going to kind of flip the scenario. And in this case, we're going to put a jar over the top of the candle and see what happens. So we're going to do our chemical reaction. And we can see we have our candle burning. We're going to put this jar over the top. And we're going to let it sit. And then we see that the flame goes out, meaning that the reaction has stopped. So it's kind of weird to think about, but burning a candle is a chemical reaction. It's a reaction between wax, which is C25H52, and oxygen. So in this particular case, again, as we watch, the candle burns. When we put the glass over the top, eventually the flame goes out, but we still have wax remaining. And so that means that the oxygen ran out first. We ran out of oxygen before we ran out of the wax because we have lots of wax left over. We can see that the candle wax is still there when the flame goes out. So this brings us to two definitions. So at the beginning, one of our learning goals is that you should be able to tell the difference between the limiting and excess reactant. So a limiting reactant is the compound that is completely consumed or used up during the reaction. The excess reactant is the compound that is not completely consumed during the reaction, and at the end of the reaction, some of this reactant will be left over. So if we take a look here, we're seeing a reaction between chlorine, which are the green circles, and hydrogen, which are these white circles. And what we can see after the reaction is that we have none of that molecular chlorine left. So no more of the green circle bonded to the green circle. But what we do see is some of the hydrogen left over right there. So hydrogen is excess because there's some of it left over after the reaction takes place. We have some of these unused hydrogen molecules. So let's go back to our burning of our candle and our explanation for why we're looking at this. So which reactant is limiting and which one is excess when we burn a candle in an open room? So if we look at the video again, we can see that all that wax is being used up, and once the wax is gone, the reaction stopped. So what that tells us is that the wax is limiting because it was completely consumed by the reaction. It was totally used up. And then that means the other reactant, oxygen, so our other reactant, oxygen, was left over. And that's why you can burn a candle in your room and not suffocate, right? Because the candle is not going to use up all of that oxygen in the room. We'd be in trouble, right? We wouldn't be able to have a fire indoors if the candle used up all the oxygen in the room. And so then let's look at the other way around. So now in the situation where we put the jar over the top, so when we put the jar over the top, we can see that that flame goes out, but we still have wax left over. Okay, so the wax is remaining after the reaction is done. So what this means this time is oxygen was limiting. When we put that jar over the top, we created a limited supply of oxygen. We significantly decreased the amount of oxygen that was there. But the wax was left over. So once the flame went out, we still could see most of that candle was still there. And that lets us know that the wax was excess because we ran out of the oxygen. So in order for a candle to burn, we need two things. We need wax and we need oxygen. So if the flame went out and we still say that we had plenty of wax, that must mean that the oxygen was the one that ran out. Now we're going to take a look at some particle models. So we can represent this same concept of limiting and excess using particle models to represent the reactions. So let's go through this first problem. So if we look here, we have a supply of hydrogen, which are these smaller circles, and then we have a supply of nitrogen, which are these larger circles. Our balanced equation is our recipe that tells us how many nitrogens and hydrogens need to be combined for a reaction to take place. So the equation for the reaction tells us that we need 1 molecule of nitrogen and 3 molecules of hydrogen to make a reaction take place. So I'm going to circle 1 nitrogen and 3 hydrogens together. Okay, so I have enough to do the reaction 1 time. Let's see if I can do it again. So I would need 1 nitrogen and 1, 2, 3 hydrogens, so I can do this reaction a second time. Now I have to stop. Okay, I don't have enough of my nitrogen to keep going and doing this reaction again. Right? So I have to stop. I have some hydrogen to do the reaction, but I'm completely out of nitrogen. So what was limiting in this particular case is going to be our nitrogen, our N2. We ran out. Okay, we have hydrogen to do the reaction again, but we have no more nitrogen left. So we completely used up the nitrogen. That's going to be our limiting. What is our excess? So our excess are going to be the things that are left over. So we can see that we have hydrogen left over that we couldn't use in our reaction. So hydrogen is going to be our excess. And then it says how many times could we do the reaction? So we had enough to do this reaction 1, 2 times. Okay. Then it asks us how many molecules of NH3 can we make given the amount of N2 and H2 that we had. So what I'm going to do for that is that each time we do the reaction, we're going to be able to make 2 NH3s. So every time we do the reaction, we can make 2 NH3s. So for this one reaction, I'm going to get 1, 2 NH3s. Then I can do the reaction a second time, which is going to give me 2 more NH3s. For a total of 1, 2, 3, 4 NH3s for my product. 4 molecules of NH3. Okay. And then it says how many molecules of excess reactant were left over. Okay, we can see that we have 1, 2 molecules left over. Okay, so that's how we would do this first one. So let's try this one more time. This time we're going to look at same reaction. We're going to have different starting amounts. So I'm going to figure out how many times I can do the reaction. So I'm going to take a look here, and I can see that again, 1 nitrogen, and I need 3 hydrogens to go with it. So here's 1 nitrogen and 3 hydrogens. 1 nitrogen, 3 hydrogens. I've got nitrogen, but I have no more hydrogen to go with it. So this time, my limiting is not my nitrogen, my limiting is my hydrogen. And then my excess that I have left over are nitrogen molecules. And how many times? I could still do the reaction 2 times this time, which means that if I can do this reaction 2 times, every time I do the reaction, I'm going to be getting 2 molecules of NH3. So there's 1, 2, for my first reaction. So my first reaction gave me 2. My second reaction gave me 2 more. For a total of 4 molecules of NH3. And then it says how many molecules of leftover reactant were there. In this particular case, we had 2 molecules of N2. So see, 1, 2 left over. Okay, and that's how we interpret a particle model.